Okay, so let's start with this new chapter. So we begin by looking at two curves. Okay, so maybe one of them does this and another one does something like that. Okay, so imagine two parabolas like this. So here we've got this function at the top. We call that the upper function. Okay, let's call that f of x. And then we've got one below that, we call that g of x. So we see that between these two intercepts of the two parabolas, let's say the first one's at A and the second one's at B. Okay, so these intersection points, A and B, these two functions produce a region. So it's an enclosed area between the upper function and the lower function and between the two intersection points. So we can highlight that as this part over here. Okay. So that region there is enclosed by the upper function at the top, the lower function at the bottom, and then between A and B, those two intersection points. Okay, what we want to do is try and find out what this area is. So that shaded region there, what is that area going to be? So we're going to start off with a little picture similar to what we had before with the Riemann sums. But we're not going to go through that whole long method of the Riemann sums. We're going to skip just to the definite integral. Okay, but this helps get the idea. So we imagine the rectangle again, okay, like we had before. But now the rectangle isn't from the x-axis up to the function. It's from the top function down to the bottom function. Okay, so we're not interested in this x-axis anymore. So this is one of the rectangles, like we had before. Yeah, sorry. Yeah, one of those rectangles. And the idea is exactly the same as what we did with the limits of a Riemann sum. We find the area of one of these rectangles, we add all of them up, and then that gives us the final area. Okay, so what's this going to be? We see from the x-axis up to the top function, that distance is going to be f of x. Okay, that's the upper function. So from the x-axis to the top, that height there is f of x. Okay, but that's only this top part. The bottom part, from the x-axis to g of x, we need to add that as well. But since g of x is below the x-axis, we know that that little height bit is going to be negative. So the actual height from the top function to the bottom function is going to be f of x minus g of x. Okay, we need to subtract g of x because that bit is negative. So minus, that makes a plus. Okay, and that gives us the height of the rectangle. The width, that's your normal dx, and then we just integrate it. Okay, so keeping that in mind, we see that the area is equal to the integral from a to b, and we took the upper function minus the lower function, that gives you the height. So it's going to be f of x minus g of x dx. Okay, so that part in brackets there, that's the height of your rectangle, and then the dx, that's the width. Okay, so same as before. Okay, now with this method, we needed to know which one is the upper function and which one is the lower function. So f, that has to be the upper one, and g, that must be the lower one for this to work. If you swap them around, you're going to get a minus sign. And we know we shouldn't be getting negative areas. Now, here we could see which one's upper, which one's lower. Now, if you don't get a sketch of the functions, you just get the functions by themselves, you might not know which one's upper, which one's lower. So in that case, we don't say f minus g because we don't know the correct order. We say area is equal to the integral from a to b, absolute value, f of x minus g of x, absolute value there, dx. Okay, so the absolute value takes care of that possible minus sign. So here, if you swap f and g, because of the absolute value, the answer remains positive, and we get the right answer. Okay, so if you are unsure about which is the upper function and which is the lower function, we can put it inside absolute values and then use our absolute value properties to decide which one's which. Okay, so we'll have a look at an example using two methods. So the first one is identifying which one's the upper and which one's the lower, just from past experience. And then we'll go through it again using the absolute value. And in that case, we'll forget about which one's upper, which one's lower. And we'll see we'll get the same answer. Okay, so let's say our f of x is equal to x squared minus 2x plus 1. And g of x is equal to minus x squared plus 3x minus 1. Okay, now here we can see which one's the upper function and which one's the lower function. Because we've got x squared, we know what that looks like. That's going to be something like this. Okay, so if it's curving like that, it must be the lower function. But minus x squared, that looks something like that. Okay, it's got that local maximum. So that's going to be the upper function. Okay, so we can tell which one's which in that case. Now, if we didn't know which one's which, then we would have to use the absolute value. And we'll have a look at that in the next part. Okay, so first we need to find where the two functions intersect, because that will give you our a and b values. So here. Okay, so we've got the upper function, the lower function. The region is between the two intersection points. So we're going to take the upper function, make it equal to the lower function. If we solve for x, that gives us a and b. Okay, so let's do that. So we're going to have x squared minus 2x plus 1 is equal to minus x squared plus 3x minus 1. Yeah, we just make them equal. Now, since we want to solve for x, we should take everything over to one side. We'll get a quadratic, and we can solve for x that way. So here, taking the minus x squared across, we'll get 2x squared. Then we have minus 2x. Then taking the 3x across, we get minus 3x. Plus 1 plus another 1, so that's plus 2. Okay, so we get 2x squared minus 2x minus 3x, that's going to be minus 5x, plus 2 is equal to 0. Okay, so we get a quadratic. We know that from a quadratic we should get two solutions. The smaller solution, that will be a, because that's closer on the left-hand side. The larger value of x, that will be b, because that's on the higher end. Okay, any questions so far? Okay, so far we're just finding the values of a and b, and they make up that interval where our region is located. Okay, so we've got this quadratic. We want to solve for x. You can use the quadratic formula. You do have your calculators available, so that's fine. Or you can factor it. So here we get 2x minus 1. That's a 1. And then x minus 2. Okay, but you do have your calculators, so please do check your answers while you're going through it. So for this first one, we have x is equal to 1/2. And for the second one, we have x is equal to 2. Okay, like I said, the smaller value of x, that will be a, that's on the smaller side of the interval. The larger value of x, that will be b, that's on the upper side of the interval. So we can say a is equal to 1/2, b is equal to 2. Okay, please make sure you don't swap those around. Okay, so the lower one, that needs to be a, the higher one, that needs to be b. Okay, so now we can write out the integral for the area. So the area will be the integral from 1/2 to 2. Okay, so from the lower one to the upper one. Then we're going to have minus x squared plus 3x minus 1. Okay, we said that was our upper function, just from experience, because we know that minus x squared has that local maximum, so it should be at the top. Minus the lower function. Just remember, if you're minusing something, put it in brackets so that when you distribute the minus sign, you get the right answer. Okay, so that will be minus, and then we have x squared minus 2x plus 1. Okay, so I'll put all of that in brackets because with the minus in front, it needs to distribute on each term. Don't just put the minus and then write the function. Okay, because then the minus will only be on the first term. We want to have it distributed on everything. Okay, so now we just expand and simplify. So we have the integral from 1/2 to 2. minus x squared plus 3x minus 1. That can stay as is, but now the minus needs to distribute. So we have minus x squared plus 2x because of the minus and then minus 1. Okay, so please remember when you're doing your distribution, just to check that. Okay, saves quite a bit of time at the end with checking your answer. Okay, integral from 1/2 to 2. Now you could just find the antiderivative like this, but it would be better to combine the like terms first. So we've got minus x squared, so that's a minus 2x squared. We've got a plus 3x and a plus 2x, so that's a plus 5x. And then a minus 1 and a minus 1, that's a minus 2. Okay, so having fewer terms, that just means less likely to make a mistake. Okay, so let's now find the antiderivative. So we've got x squared, so plus 1 to make it 3, divide by 3, so minus 2/3. Okay, we've got 5x, add 1 to the exponent to make it 2, divide by that, so we have 5/2. Here we just have a minus 2, so we know it's just going to be a minus 2x. Okay, bottom is 1/2, and top is still 2. Okay, now we can substitute our values. So we're going to get minus 2/3 2 cubed, plus 5/2 2 squared, minus 2 times 2. Okay, so that's substituting the upper bound. Remember, upper bound first, minus, and then you substitute the lower bound. Please don't swap those around. Okay, so then we're going to have 2/3 and then 1/2 cubed, plus 5/2 1/2 squared, and minus 2 times 1/2. Okay, so you can simplify this. It's not so bad. You can do it in your head, but again, you do have your calculators, so make use of them. So we get 1.125. Okay, so you can just check that on your calculators when you go through this again. Okay, so once you've identified which one's the upper function, which one's the lower function, then you find your a and your b, and then you evaluate the definite integral. Okay, yeah, question?
So, isn't it meant to be minus 2/3 when you're solving it?
Where's that?
Second last one.
This?
Yeah.
Yeah, that's badly drawn too.
So you put a bracket that means you multiply everything by an factor.
Yeah, so the minus is there from your antiderivative at the upper bound minus your antiderivative at the lower bound. Okay, so this step here, that's my capital F at B minus that. Okay.
So,
Yeah.
no, it's meant to be a minus 2/3.
Oh, minus 2/3 there. Yeah. Yeah, there's a minus there. Okay. Yeah, check your minus signs. Okay, yes?
After equating the equation at simply for x, how do you see which one is A, which one is B?
So here, A, that's your smaller value of x, and then B, that's your larger value of x. So it's always on some interval. So when you have your curve like this, okay, like this, you're going to have one intersection point here. Okay, we call that A, and then you have another intersection point at the other end, we call that B. Okay. Okay, is that all right? Hello? Good? Okay. Any other questions before we move on? Okay. Okay, so this is if we know which one's the upper function and which one's the lower function. Sometimes we don't know which one's the upper or which one's the lower because it's too difficult to sketch, or maybe it's a new function you haven't seen before. So in that case, we can always use those absolute values, right? So the absolute value of f of x minus g of x, it doesn't matter which one's upper or which one's lower, we still get the same height of the rectangle. So we can do the same thing here. So let's say f of x is equal to x squared minus 2x plus 1, and g of x is equal to, we had minus x squared plus 3x minus 1. Okay, so same functions as before, but now we're going to pretend we don't know which one's the upper and which one's the lower. Okay, just a note from previous years teaching this, these questions are answered very, very poorly because the students don't know how to work with absolute values. Okay, so please, if you are unfamiliar with absolute values, like absolute value x plus 2, so if you can't sketch that, you don't know what it means, please go over your work or see me in my office and I can help you out. Okay, we won't be going through absolute values because that's been done before, but if you do need help, you can see me one-on-one or you can ask the tutors. Okay, but we won't be going through it again in the lectures. Okay, so please just keep that in mind. Just from previous years teaching this, this has been answered very poorly. Okay, so here we're going to look for the absolute value of f of x minus g of x. Okay, so now I put f first. Now we know that that's not correct. It should have been g minus f, but this is just to show you that it doesn't matter which way you put it. You'll still get the same answer. Okay, because of those absolute values there. Okay, so this is going to be absolute value of f, so that's going to be x squared minus 2x plus 1, minus, and then g, that's minus x squared plus 3x minus 1. Okay, again in absolute values. So once we simplify this, we're going to have the absolute value of a quadratic, okay, and then from that we can determine what we need. Okay, so here absolute value, x squared minus 2x plus 1, and again the minus, that's going to distribute, so we have minus x squared, so that's plus x squared, then minus 3x, and then plus 1. Okay, so x squared and another x squared, that's going to be 2x squared. Okay, and then minus 2x minus 3x, that's going to be minus 5x, and then the 1 and the 1, that makes it 2. Okay, so absolute value of this. So what we want to do is determine what is the absolute value of this function. So finding the absolute value of just a number, that's easy to do, but what about a function? So here we'll see that if we have something like this, okay, something like that, let's say that is our function, right? It might not look like this, but just for an illustration, if we take the absolute value of this, we're going to end up with something like this. So it's going to come down again, but now where the parabola was negative between those 2 points, it now becomes positive, so it's going to look like this. Okay, and then it's going to go up again. Okay, so you see that taking the absolute value of a function gives us back a different looking function where all of the negative parts, so this bit over here, now moves to the top. So when we do the integral over this new function here, we're only adding up the positive terms. Okay, there's no negative parts anymore. Okay, so what can we do here? Okay, so let's continue. So we have absolute value, 2x squared minus 5x plus 2. Okay, so I'm just going to factor it again like we had last time. Again, please go over your factoring. It does make it easier than using your calculator. So we're going to have 2x minus 1 and x minus 2. Okay, so these give us our critical values, as you would have called them in high school, of x equals 1/2 and x equals 2. So we can draw our number line. So here x is 1/2, here x equals 2. Okay, now again we want the absolute value. So we need to see where's this function positive, where's this function negative, and put the minus sign in accordingly. So if we look below 1/2, it's going to be positive. You can just substitute. Okay, you can substitute 0, for example, see what you get. Then between 1/2 and 2, you can substitute something, you'll see it's negative. So, for example, substitute 1, you can see what you get. and then something after 2 as well. Okay, so it's going to be something like this. Okay, so once we've got that, we can see that between 1/2 and 2, the function is negative. So if we want to take the absolute value of it, we need to put a minus sign in that case. So absolute value of 2x squared, 2x squared minus 5x plus 2 is equal to, okay, and this is where we use that definition. So the absolute value of x, just x, is equal to x if x is positive, it's minus x if x is negative. So we're going to use the same thing here. So the absolute value of the function is equal to just the function if it's positive, and we know where it's positive. So it's going to be 2x squared minus 5x plus 2. Where is it positive? Before 1/2 and after 2. Okay, and then we see that between the interval it's negative, so we have to put the minus sign. So now we put the minus sign, and then 2x squared minus 5x plus 2. So this is between 1/2 and 2. Okay, now we can simplify that a bit. So the absolute value now becomes this split function or piecewise function. So we have 2x squared minus 5x plus 2 for x is less than 1/2 or x is greater than 2. And then distributing the minus sign, we have minus 2x squared plus 5x minus 2 if it is within the interval. Okay, so from a single function, we now get a piecewise function depending on where we are. So when we are integrating from some lower bound to some upper bound, we need to keep in mind which function we're actually using. So if our bound includes this interval, so if we're going over this interval, we use this part of the function. If we're integrating and we're outside of the interval, we use this part of the function. Okay, so depending on where we are, we're going to use either the top part or the bottom half. Now, in our case, this bottom part is only going to be used because our interval goes from 1/2 to 2. Okay, so we only use the bottom part. We'll see for the next example that that's not always the case. For 1/2 of the interval, you might use the top part of the function. For the other part of the interval, you might use the bottom part of the function. Okay, just depends on where you are. So here, it's not so bad because we're going to go from 1/2 to 2. Absolute value of 2x squared, minus 5x plus 2. We see that over this integration domain 1/2 to 2, we're only using this bottom part. Okay, so it's quite easy. So this just becomes the integral from 1/2 to 2 minus 2x squared plus 5x minus 2 dx. Okay, and you'll see you'll get the same answer with that. So in this case, it was quite easy because this integral over here, the bounds only appeared for this bottom part. Okay, again, sometimes that might not be the case. All right, any questions on that? Okay, so let's have a look at an example where this is important. Okay, so let's say we have the following situation. Okay, so we've got a parabola, y equals x squared, and a straight line, y equals x plus 1. Okay, so for this one, we're not going to be interested in these intersection points. We're going to provide our own bounds, and that's going to be from minus 2 to 3. Okay, so now we're not looking for this bounded region in the middle. We're looking for the bounded region between minus 2 and 3. So now we're including this bit over here, and this bit over here. Okay, so now it gets a bit more complicated. We see that over this interval from minus 2 to 3, the upper function and the lower function swap a bit. So we see that from minus 2 up to this intersection point, the upper function is the parabola, and the lower function is the straight line. Then, from this intersection point to this other intersection point, the straight line becomes the upper function, and the parabola becomes the lower function. Okay, so they swap roles. Then, after this intersection point, for this bit here, the parabola now becomes the upper function, and the straight line becomes the lower function. Okay, so you see that over this interval, the upper function and the lower function swap a bit as you go. Okay, now this is where we need to use the absolute value. Okay, because of this, the problem of swapping. So what you could do, okay, so this is fine, you could find these intersection points if you wanted to, and then split this up into 3 integrals. So you can have the integral from minus 2 up to the first point, and this is if you know which one's upper, which one's lower. So from minus 2 to the first point, we know the parabola's above and the straight line's below, so you put that down. Then you go from this intersection point to this intersection point, with the straight line being above and the parabola being below. And then from this intersection point to the end, where the parabola's above and the line's below. Okay, so you can split this up into 3 integrals if you do know which one's above and which one's below. Okay, so if you do know, you can do it like that. If you don't know, we can just use the absolute value method. So let's do that. So we're going to look at the absolute value of, again, doesn't matter which one's which. Let's take the parabola first. So x squared minus x minus 1. Okay, so we need to find this. And we'll see that this is going to be split up into 3 parts. We're going to have one part over here. Okay, over there it's going to give us a value. Over here it will give us a value. And then over here it will give us another value. Okay, so how do we do that? First, we need to find where this function here is positive or negative. Okay, where it's negative, we put the minus sign. Okay, so let's find the roots. Find the roots to see where the function is positive and negative. Okay, so before one of the roots it will be positive, between the roots it will be negative, after the final roots it will go back to being positive. And we can tell that just from the shape, right? It's a positive parabola. So it will be positive, negative, positive for our line. So x is going to be equal to minus b plus minus square root b squared minus 4ac all over 2a. Okay, a is just 1. Okay, so x is going to be 1 plus or minus root. We're going to have 1 minus 4, but times the minus 1 there, so it will be 1 plus 4, so 5 over 2. Okay, so which one's the lower, which one's the upper? Again, you can just put in your calculator and see what the value is. But the lower one, let's call that x1. That will be 1 minus root 5 over 2. And then the upper one, that will be 1 plus root 5 over 2. Okay, so that's where the function is 0. So we can put this on our number line. So those are x values. At this point here, 1 minus root 5 over 2, and other root here, 1 plus root 5 over 2. Okay, we know the shape of the parabola, happy face parabola. So on the first section here, it's going to be positive, negative, positive. Okay, so that's our splitting up of the region there. Okay, so we know that there's the minus in between there. So we can use that to say that on that region, it's going to be minus whatever's inside the absolute value. Okay, so absolute value of x squared minus x minus 1. Okay, we can split this up into 3 parts. Okay, so the first part will be up to the first root, where it's positive. Since it's positive, we can just leave it alone. So it will be x squared minus x minus 1 for x being less than 1 minus root 5 over 2. Okay, you can put a equals as well. Okay, then between the two roots, the function is negative. So it's going to be minus whatever's inside the absolute value. So it will be minus x squared minus x minus 1. And that is if x lies between the two roots. So it will be 1 minus root 5, 1 minus root 5 over 2, up to 1 plus root 5 over 2. And finally, for that last bit after the second root, the function is positive, so the absolute value doesn't do anything, so we can just rewrite the function. And that is if x is after the other roots. Okay, so we've got this piecewise function for the three regions that we've got. So now when we're integrating this function, it's going to split up into the three regions as well. Okay, so remember it went from minus 2 to 3. So from minus 2 up to the first root, that's going to be the first part. From the first root to the second root, that will be the second part. And then from the second root to 3, that will be the third part. Okay, so I'll show you what we do now. So we have the integral from minus 2 to 3, absolute value x squared minus x minus 1 dx. Okay, like I said, this is going to split up into the three parts. So we're going to have the first part from minus 2 up to the first root. And since the function is positive on that bit, we don't need to do anything. It stays the same. So we're going to have the integral from minus 2 up to 1 minus root 5 over 2. And then the function stays the same. Okay, so that first part, the function's positive, so it stays the same. Plus, and then we have to integrate over that second part. So that will be from 1 minus root 5 over 2 up to 1 plus root 5 over 2. Now, over this part, the function is negative. So we need to use that middle bit, this middle part here, with the minus sign so that the result is again positive. So it will be minus x squared minus x minus 1. Okay, again, the minus sign is because the function was negative, but we need it to be positive. And finally, for the third part of the region, plus the integral from 1 plus root 5 over 2 to 3. So on this part, the function was positive. We saw that here when we took the absolute value. So we just need to use that part over there. Okay, so that's going to be x squared minus x minus 1 dx. Okay, so this is what I mean with the absolute value splitting up the region. So we had some large region where the function was positive sometimes, it was negative sometimes. When we take the absolute value, that's going to split it up and include a minus sign, this minus sign over here, okay, for this part here. Okay, you need to put a minus sign if that region has a negative function value. Okay, so here the first bit, that was positive, we left it alone. For the second bit, we saw from our number line that it was negative, so we have to put the minus sign. And then for that last bit, our number line said it was positive, so we just leave it alone. Yeah. Then for these three parts, that we get these three integrals over those three regions. All right. Any questions on that? Okay, so everyone's all right with that. Okay, and then these three, you do your standard FTC to evaluate. Okay, so the main part is finding where's the function positive, where's it negative, and finding those regions where it's positive and negative. If it's negative, remember to put a minus sign in front. Okay, any questions before we move on? Okay, let's have a look at another example. Okay, again, I'll draw a picture just so that we can see what's going on. But remember, in the test, you're just given F and G. The picture's not given to you. So you go straight to the absolute value if you're unsure which one's positive and which one's negative. Okay, but here I can provide the picture for you to see. Okay, so let's say we've got something like this. So y is equal to 2x squared minus 1. And then we've got a straight line. Y is equal to 2x plus 2. Okay, again, the picture is just so that we can see what's happening. That won't be provided. You won't need to sketch it. It's just for us to see what's going on. Okay, and now we want to find the enclosed area from here at minus 5 to here at 5. Okay, so that is our region. So we can just sketch that in. So it's going to be this part, it's going to be this part here, and this part over there. Okay, and again, just from the picture, we can see that the upper function and the lower function swap as we go along. So from minus 5 to the first intersection point, the parabola is above the straight line. Then from the intersection point to the other intersection point, the straight line is above the parabola. And then from that intersection point up to 5, the parabola is then above the straight line. Okay, so we have that swapping going on. Okay, so because we've got that swapping, we're unsure which one's above, which one's below. We use the absolute value to split this up over the 3 regions. We're going to have region 1 over here, region 2 in the middle, and then region 3 at the end. And we get those regions from the absolute value. Okay, so absolute value. Again, doesn't matter which order you do it, you're going to get the same answer. Let's do parabola minus straight line. Okay, you can do straight line minus parabola, you'll get the same thing. So it's going to be 2x squared minus 1 minus, and then the straight line, 2x plus 2. Okay, again, doesn't matter which way you do it. Let's simplify this. So we're going to get absolute value, 2x squared minus 2x, and then we're going to have a minus 1 and a minus 2, so that makes a minus 3. Okay, again, we want the absolute value of this function. Okay, so as with all absolute values, if the inside part is negative, we want to put a minus sign. If it's positive, we leave it alone. So this parabola here, we want to see where's the parabola positive, we just leave it alone. Where's the parabola negative, we put a minus sign. Okay, and it's a happy face parabola, so we know the rough idea of what it's going to look like. So let's see where the roots are. 2x squared minus 2x minus 3 is equal to 0. Again, you can factor it, use your calculators, whatever you're comfortable with. So let's use the quadratic formula. So we're going to have minus b, so that's 2, plus minus the square root b squared, that will be 4, minus 4ac all over 2a. Okay, again, if you can factor it and that's quicker for you, that's fine. Okay, so we're going to get 2 plus or minus square roots, 4 plus, we've got 2 minuses there, so it's going to be a plus. So 4 times 3, that will be 12, times 2, that will be 24. Okay, and it's plus because of the minus and the minus. Okay, all over 4. So that will be x is equal to 2 plus or minus root 28 all over 4. Okay, and you have your calculators so you can simplify that if you need to. Okay, so we're going to get 2 roots. We're going to get x1, let's say that's the smaller one. So that will be 2 minus root 28 over 4. And then x2, that's the other root, 2 plus root 28 over 4. Okay, so those are the 2 roots of the parabola. Between the 2 roots, it's going to be negative because it's a happy face parabola. Outside those 2 roots, it's going to be positive. Again, because we know it's one of those happy face parabolas. Okay, so number line. We know it's going to be happy face, something like that. We've got x1 and x2 like that. So before x1, the function's going to be positive. Between x1 and x2, the function's going to be negative. After x2, it's going to be positive again. Again, happy face parabola, it has to look like this. So this gives us the 3 regions where we need to consider, do we put a plus sign or do we put a minus sign? Okay, so finally, absolute value of 2x squared minus 2x minus 3 is equal to, and then we're going to have three parts. We're going to have the first part where it's positive, the part where it's negative, and then the part where it's positive again. Okay, so for the first bit, up to x1, the parabola is positive, so we don't need to do anything. We can leave it as is. So this is for x before the first root. Okay, then between the roots, it's going to be negative, so we need to put a minus sign. So it's going to be minus 2x squared minus 2x minus 3, and that is if we are between the roots. And finally, after the second root, the parabola is again positive, so we don't need to do anything. We can just write it as is. Okay, and this is after the second root. Okay, so we have the three regions, and since we took the absolute value, whatever's on that right-hand side is guaranteed to be positive. So we don't have to worry about any signs there. Okay, we've got the three regions. We can now split up our integral. So the integral from minus 5 to 5, absolute value, 2x squared minus 2x minus 3. This will split up according to our absolute value function. Okay, so the first part will be from minus 5 up to the first root. Let's just call that x1. And we look on the right-hand side here, we need to take this first part of the function. 2x squared minus 2x minus 3. Plus the integral from x1 to x2. So that is that middle bit here. So here we need to put a minus sign in front. So let's do that. Okay. And then from the second root up to the end point, the function's again positive. So we don't need to do anything there. So that will be the integral from x2 to 5 to x squared minus 2x minus 3. Okay, and then that's just your normal FTC to evaluate that. Okay, so here I'll put x1 and x2. So you would substitute these values here. Okay, so you've got your calculators. You can just find what those values are. Okay. Any questions so far? Okay, no questions. Okay, so let's just put a little summary of what you need to do. Okay, so let's say we have some function f and some function g. I'm not going to say which one's upper or which one's lower. Okay, we might not know. Okay. And some endpoints A and B. Okay, so this is like those last two examples where we have endpoints, but between those endpoints the functions swap between being upper and lower. Okay, so the first thing we do is need to find absolute value f of x minus g of x. Okay, so this will be equal to some number of functions with or without a minus sign, depending on whether that interval has a negative function value. So this will be some number of functions. Let's say that the first one goes from x is less than or equal to a. Okay, a less than or equal to x less than or equal to b, and then x is greater than or equal to b. For example, whatever those values might be. Okay, so once you take the absolute value, it will split up into the different regions. Some parts will have a minus sign, other parts will have a plus sign. So maybe it looks like this. So plus, minus, minus, for example. Okay, so for the first bit, you put a plus sign. For the second two parts, the function was negative, for example. You would put a minus sign in front. Okay, and then that gives you your splitting up of the function. Then when you want to find the integral from a to b, absolute value, f of x minus g of x dx, this will then split up into however many intervals you have. So you have the integral for the first bit, plus the integral for the second bit, plus the integral for the third bit. Okay. And these integrands here, so this bit here, this bit here, and this bit here, that will depend on which one you choose here. Okay, depending on those x values. Okay, then you just add everything up and then you get your answer. Okay, so you'll use this method if you're unsure which one's the upper function or which one's the lower function, or in this case here, that we had in this previous example, sometimes it swaps between being an upper function or being a lower function. Okay, in that case, you would have to use the absolute value. If we go back to that first example here, okay, in this case, the endpoints coincided with the intersection points, so we know for sure that between these 2 points, f is upper and g is lower. Okay, so we know for sure in that case. For the other cases, if we're not sure, we use the absolute value. Okay, but just keep in mind the absolute value works for any cases. Okay, so it's not for a specific case where you don't know. You can use it for anything. Okay, any questions on this? Okay, so Wednesday we'll go through some more examples. We'll go through the 10 from the tutorial, so you can prepare that beforehand, and then we'll go through another 10 that are unseen. Okay, so it will be the same as last time, where you can get up to 40 points. Okay, and then that will all be towards the assignments. Okay, any questions before we go? Okay, cool. I'll see you Wednesday.